So there's a suggestion here that if we work that out, it's actually $1,778. Did anyone else get that? If we had 45 rows? Because there's going to be $79 for each 2 rows. So there's going to be 44 lots of 79, plus there's going to be one more 50. Yeah, so. Okay. To do that, what actually turns out to be quite a lot more than the square in order to do that. This, by the way, I think is probably the easiest method to work it out accurately. Is that what answer did you get when you tried it out, though? Oh, okay, so you did to do that. To do that. So, did anyone, by the way, use sine to do this? Sine 60? Oh, you people, yeah, I did too. Which is actually harder because you got to remember what sine 60 is, but to do that. So, did you get the same answer in the end? Yeah, but so to do that. Can you see that is the same lesson as the one with the pens? It's the same lesson to do that. Now I guess that's the sort of lesson, you could do it at year 7 and forget the extra stuff, or you could do it at year 11. So it's actually where they're really starting to use Pythagoras theorem or trig or something to actually do some calculations. But we can actually do it at grade 2, the same lesson. So if you can imagine I had a box of chocolates, I don't here, but if you had to imagine just a normal rectangular box of chocolates and I had 3 chocolates left. Can you see the box and the 3 chocolates? How many chocolates were in the box to start with? Could be the lesson for grade 2. And it's the same lesson. So what does the lesson consist of? Okay, after posing and clarifying the problem, the teacher asks the students to record an estimate. This is the template. Students invited to think about what strategies they use to calculate an answer. First individually, then brainstorm as a group, and the groups report strategies to the class. Groups choose or are allocated a strategy, they implement the strategy and prepare a report. And you might, by the way, with this type of lesson, have the kids get into the habit of actually writing a report. Oh, sorry, I'll go back to that for a minute. So that's, if you like, the first 3 phases, first 3 steps in this template. And you can imagine there's any number of examples that we could use this template for. It's anything like where you're trying, and why it's called imagine representations. Sometimes I use an example of if we were trying to replace the arms on the statue of Venus de Milo, how long would we make the arms? It's the same lesson, where you make an estimate, discuss a strategy, do something about it, and then I'll talk about the next one. So there's any number of, how many people could fit in this room? How many balloons would we need to cover this part of the roof? Any sort of estimate that we might be doing, we could actually use the same sort of strategy to do that. How many people might turn up at a particular function? How much would we need to provide light beer to the 18-year-olds? It's close-ish to a Fermi problem. In this case, in the coins case, there was a specific answer. In the fractions case, there was. In the chocolates, there was. In a sense, the Fermi problem don't have a specific answer, but the same idea. And you would use this template for a Fermi problem. A Fermi problem, by the way, which is named after Enrico Fermi, his famous one was, how many piano tuners do you think there are in Chicago? Well, who has not heard of Fermi problems? Okay, but just by way of an example, just to show you what it is, here's the question. You people look like that you're coming up to this, so I can say this. How many people are going to turn 40 in Australia today? Can you write down a guess, please? Okay, so you've written down a guess? Okay. Can you now talk at the people at the tables? Don't work it out yet. Talk about how you might work it out. And come to agreement at your table about how you might work it out. Through a strategy. Now, I'm not interested in the answer at the moment. I want the strategy you might use for working out the answer to this question. What about your table over there, Linda? What's it? Okay, so the 1 in 365 is going to be important in the answer. Okay, all right. Who got a bit further along the way?
Sorry, I didn't quite hear.
Yeah.
You said population of Australia, divided by 365, gives the number of birthdays today.
Yeah.
Divided by the average age expectancy, assuming the median spread of people.
Okay, all right, so that's a nice strategy. So that would be a good strategy to work it out. Who's got another way of working it out?
Well, I was thinking we could use the register sample and use the family membership in this group and see how many actually work to report in and affect that one.
Okay, we could actually do a survey of people in this room and take, if you like, their families, and we can get all of the data and collect some data on it and actually work out something about population demographics based on us and our families. That would be an interesting thing to do, an interesting exercise to do. Who's got another suggestion?
We did very similar to them, but we said that we could take 1 to 80 years old, and we said, so that's theoretically 1 out of 8 chance, but we know that we have an aging population, so we rounded that up to 1 out of 50, so the 1 out of 50 is 40 years old.
Yeah.
Divided it by 3.
Okay, so it's similar method to that. So it's a really nice way of doing the calculation. All right, could you, not your method because it would take us too long, but can you have a go, just a few more minutes to work out an answer, please? Can we just hear some answers? What you said? Okay, let's call it 1200. What did you guys get up there for your answer? What was your answer? Oh, okay. All right. Well, what did you guys get? We're still going. Okay. So if you took, the population of Australia is actually now 22 million. Did you hear that thing on the radio that they said that this was a few weeks ago, the 22 millionth Australian was going to be born that day, and it was likely that that would be a boy called Jack. And the thing that's interesting is because the probability of a boy is slightly higher than the probability of a girl. It's sort of like 0.51, 0.49. And Jack is the most common name, in the last year. So even though the probability of a boy named Jack was probably, 0.001 or something, it was still the most likely outcome for that. Anyway, there's 22 million. If we divide it by, a lot of people said, let's secure life expectancy 80 and say people are evenly distributed with the hope that 40's in the middle somewhere. So we can divide 22 million by 80. Yeah, by 80. And then divide that by 365, and that would give us the answer. So to do that.